So, welcome everyone to the Open Security Summit March 22. And we are doing Ask Me Anything with Brook Schoenfield. Now, I've known Brook for a number of years now. We met when we were at the founding event of the IEEE Center for Secure Design. And I have to say that I divide my career before Brook and after Brook for a number of reasons that will become apparent soon. So Brook is a very well-known thought and industry leader. He has been a distinguished engineer at Intel. He has worked at the McAfee, Cisco, Autodesk. He has participated in the founding of the IEEE Center for Secure Design, and he is a collaborator at SafeCode. He is one of the authors of the Threat Modeling Manifesto, and Brook is featured at the Bletchley Park Museum of Computing. Apart from that, Brook is a master threat modeler, and I like to think that if Adam Shastak is the Feynman of threat modeling, then Brook is certainly the Shakespeare. And he is a veteran security architect, a prolific author. He's authored Securing Systems. He's authored The Secrets of a Cybersecurity Architect, and most recently, the Building in Security at Agile Speed. Brook writes blogs, gives presentations. He can be found in many instances at YouTube. And he mostly talks about developer-centric software security, threat modeling, secure design, secure development, risk modeling, vulnerability management. And apart from all of that, Brook is probably one of the kindest, most supportive, nicest people in an industry that is known for not being exactly welcoming of new people or supportive of new efforts. So he's a mensch, a philosopher, and an outright great guy. Yes.
Don't believe a word he says, not one word.
So without further ado, Kate, if you can advance to the fourth slide where we have the questions.
Can I say one other thing?
Later.
What happens when you have a long career and you won't keep your mouth shut? You produce a lot of stuff.
You get good things passing for the next generation.
Well,
so,
hopefully.
The first question that we have here is, can you explain what's in it for security leadership?
Well, I'm not quite sure what's in it means, to be honest. There's a couple different angles here. Why be a security leader? Well, why be a leader anywhere? Let's just start there. In a world where vacuums of leadership will attract those who want to take care of their personal self-loathing and work that out on everyone else, if the rest of us will step up just a little bit and show some leadership, we don't have a vacuum, and then we get leadership. And so my ideas about leadership are, it's really for all of us. And that's something I learned years ago. For a little while, I was an anti-nuclear activist. I didn't really like the work. And my position on nuclear power has changed radically. However, that's a different story. We'll leave that off and just say that at the time, it seemed like the right thing to do. Didn't really like the work. But one thing that I did learn is about leadership a lot, and sharing leadership and being a leader without being, what's the right word? I'm thinking of the word a-hole, which isn't the right thing to say in a recorded thing, but I can't think of a nasty human being. So how to show leadership without being the leader. And you show leadership by saying, hey, I know how to do something and I'll take responsibility. Really, that's all it is. And the more we take responsibility, people we don't want to be leaders don't have room to get in there. So I encourage everyone to step in and just take responsibility and add what you can. And it's amazing when that happens. As my friend Vinay Bansal once said to me about a team that I had been the technical leader for, but he said, Brook, we could move mountains. And I really believe that's true. So what's in it for leadership? Just do it. What's in it for security leadership? Here's the deal. The problems we're facing are really hard. They're really complex. And if we don't get on top of this, and let me step back just a minute from that statement. I'm going to come back to that. But importantly, for about 4, maybe by now going near 5 billion of us, our lives are so intertwined with bytes and bits and 2's complement arithmetic, which is what it all comes down to, by the way. I'm just teaching a course at the university here in CPU architectures, and I was reminded how very simple it is at the bottom. Boolean gates and 2's complement arithmetic. So that's a little computer science for you. If you don't know that, that's fine. You don't need to. But our lives are intertwined. And if we don't secure it, there's so much opportunity for so many things, so many different ways of opportunity to take advantage of our bad security. Or as John Stewart and I were once getting on a plane to go, we were both speaking at the same conference, and I saw him at the airport, and we had a chat, and I was talking about, kind of what's in it for security leadership. And John said, just keeping it usable would be good. And I think that's a kind of a fair summation. Just keeping it all usable rather than a big pile of cards and mess. So we have a big charge. We really do have a big charge. And I don't mean to self-aggrandize myself or anyone else. There's a lot of us in on this, but it's a big charge. And I don't let that stop me with overwhelm in my daily work, but I try to keep it in mind that the ramifications of what we do is more important than just securing this app or that app. It's bigger. And because of that, and we're going to need leaders. And I know leaders. I know some fantastic leaders. When I look at someone like Adam Shostak, like Izar, who is probably one of the most delightful people to work with I know. We've written now almost one manifesto and looks like 3 books together. Yeah. So, and I helped you with yours. So that's 4, right? Yeah, so we've been around the block together a bit. And his humility is something really special, I'll tell you.
It's not about me. Now, extending that a bit, before we jump to the next question from the public.
Sure.
You touched into something very, very important. You yourself, you are very used to talking to C-level people about security. You have been a director of security. You have been in the high posts of security in many, many big corporations and important places. Now, how would you translate security leadership for the person coming in now into the scene? For the security engineer that's working with a product team, for the people that are just coming in the pipeline? How would you tell them, hey, here's how you exercise security leadership at your level, and this is what you get from it?
Right, that's a great question. I luckily, or horribly for all the people I've worked with, I mean, you have to talk to them, but luckily I've worked with hundreds of people who've become, security engineers or security architects or whatever. And I think the most important thing is just to take the first few steps and do whatever you can do. One of the things that's one of my maxims is never refuse any help. And that's very exciting for people to know that they're seen as valuable, and what they have to offer is important and valued and will be at least listened to. So, one of the things that I try to do or aspire to do, because I'm not perfect by any stretch, is to really, when people say, I want to do X, Y, Z, unless it's going to lead to a catastrophe, I like to say, go for it. How can I help you? And let's see what happens, because maybe I'll learn something and maybe I'm wrong. That's always a possibility. Or we'll all learn something. A little story, and this comes from my friend Steve Atchison, who was a very good security leader, by the way. When I was first starting to be a security architect, I was about 2-3 years into my security career, already into my high-tech career, 12 years, 13 years or something like that. And one of the people on our team built a spreadsheet to rate risks. And Steve saw that it had a huge mistake in it. And I'll tell you the mistake in a minute. But he didn't say anything because he knew that it was worth us going. And for 2 years, 3 years, we collected those numbers. And what would make them all trend to medium? A little mathematical mistake, a little statistical mistake. They were averaging them, all the risks. You can't do that because the average is usually medium. And so all of our tended risks were tended when you did an aggregate that our risk was medium. So there was a little mathematical mistake in there, a little statistical mistake, but Steve said not a word because he knew one day one of us at least would wake up. And a few years later I went, oh, we can't average that. And he went, yeah, that's great leadership. Because how would I have started on my journey to really understand risk better and the math behind it and what you can do and what you can't do and what it is if I hadn't made a huge 3-year mistake? Now, they weren't my numbers, but I was willing to go for it because sure was better than anything I could think of, and I didn't know anything at the time. So that's what I would say to people. Try. See what you think. If you have an idea, try it, go for it. Because even if it fails, like that risk spreadsheet, it could lead to something like learning FAIR, factor analysis of information risk, studying with Jack Jones. Many times, the inventor of that was a dear friend of mine. And then coming up with just good enough risk rating, which you, when you were at, was it EMC, actually adopted it, And so that's the kind of learning that I encourage people to do. Just step out. You got an idea, try it, see what happens. Because and again, this is, you and I just talked about this not too long ago. The leader's job is to make sure no catastrophes happen, or as few as possible, and they're limited. And that's kind of what I see my job as doing when I'm encouraging people. Try it, see it, find out, get in there. And then, you can, the leader's job is to get in there and say, well, you're fighting over this rather low risk issue with this development team. Why are you doing that? So that's something I've said to tons of practitioners. Why are you fighting over that? You're wasting your influence. They're not going to listen to you if you come up with a high one now. So, don't do that, for instance. And you can kind of then be there for people. I guess that's what I would say to the people coming in. Try, do. How can we encourage you? How can we encourage diverse voices?
Awesome. Okay, the next question that we have is, Katie? Oh, yeah. What additional competencies or capabilities will you need if you want to lead your field in the years ahead?
Don't ever stop. First thing is, I don't stop ever looking at new stuff. If somebody declares a new exploit, an entirely new exploit type, I reserve time to go and actually study it and understand the computer science of it. And maybe it's not real new. Like, for instance, some new Spectre meltdown variations were just announced about a month ago, I think. I was right down there looking at, what is this? Is it really new? What are those guys up to again? Because that's a very important piece of our staying alive. And I'm always learning about new technologies, always, right? There's no way you can know it all. So, you know, I get a job, I consult. And so if I get a job that requires me to go to do research, well, I go do the research and I figure it out if I can, or get help. So that part of it, the technical part of it, you can't ever stop. Not in our world. On the other hand, spend time with the soft skills.
Yeah.
Spend time with the soft skills. I know it seems, you know, especially for engineers, they're like, yeah, I just want to code. Yeah, that's okay. But if you want to be a leader, spend time with the soft skills. What you see, the person that Izar described is a construction of a lot of practice. Because what I come from is a totally screamy, beat everybody up family with not a lot of money, but plenty of smarts and education. That's my natal, like, this is my family of origin, is to scream at everybody and jump up and down and try to get my way. And I might be slightly, maybe on a scale towards autism a little bit too, which is not unusual for engineers. So I've practiced a lot. The person you see has practiced. I have been in dozens of active listening exercises in my life, dozens, to learn how to do that. I have been in dozens of empathy type of exercises to really look at someone and think about how they're feeling and let myself feel that too. Tons of exercise in terms of giving and receiving feedback, a very hard thing. Does my belly want to do flip-flops when somebody says, I got to talk to you about something, Brook? You bet it does. But, you know, where there's fear, there's power. And so I'm going to walk in there and do my best to be gracious and say I'm wrong and hear what the other person, why they're hurting or whatever, and thus model the kind of behavior I want to get as well. And so all of these soft skills, there are a lot of construction there. People see me present and they say, wow, that's really great. The first time I presented at a major conference, I was talking like this because I was so scared. And I had 50,000 words on every slide because it was my outline, so I wouldn't forget. Yeah, I was terrible. It's a construction. So if I can slow down and just say, if you do the soft skills, if you practice, you can change and you can be. And some of that, I hate to say it, is going to be, you know, learning about yourself and your own triggers and the things that hurt you, that don't hurt other people, and things that you can tolerate that other people get hurt from, and all of that soft, you know, smushy stuff. As you grow and people look up to you, you can either let yourself believe your publicity, or you can do the work. But there's no, that's a hard binary. That's a hard line. You can't, I don't try not to believe. Izar said all these nice things, and thank you very much. And they're wonderful. But I try not to let that be my self-image, because that way lies being really pretty awful.
Okay, so let's operationalize the question just like we did with the first one. This last Monday, you and I sat down.
Sorry, Izar, can I?
Oh, sorry, go.
Can I throw a variation of this question that you have here?
Can I just interject this, then we get yours?
Well, this is related to this one.
Okay, cool.
So a lot of the stuff you talk, Brook, are things that I would say remove security out of it, and that will be applicable to any professional. Would you agree?
Absolutely.
Okay. Now, let me flip the question to say, what are the competencies and capabilities that you need if you want to be a lead in your security field? So this
Yeah,
is
right.
specifically to cybersecurity, specifically to security, not something that other engineers or other professionals or doctors or poets or whatever or managers should have. But what you could say that it's a little bit unique about our field.
Okay, there's two things. There's three things. First of all, learn to threat model. Really, threat modeling, in my opinion, is fundamental to everything we do. So let's say you're a CISO. And that seems like, yeah, threat modeling, that's something the security architects or the security engineers do. Wrong. You've got an organization. You've got to think really macro here, really big, but you still got to think,
Yeah.
where are my threats? And what are the programs that are going to move the dial in the right way? It's still threat modeling. And so learn to threat model. That's number one. If you learn to threat model, you better learn something about risk. We throw that term around all the time in this industry, and more. I don't know the percentage. The vast majority of people, when they throw around the word risk, actually don't mean the same thing that I mean. And that's really dangerous. And so learn what risk is and how it can be calculated in the absence of actuarial tables, because that's actually where we are in our current situation. Is we don't have actuarial tables, or we only have very limited ones. So we can do a little with breaches, say, but you know, and the Poneman Institute, by the way, if you want to go look at what can be done, go to the Poneman Institute. They've done some fabulous stuff. Okay, so risk, really important, because once you threat model, what are you going to do with it if you can't come up with some risks? Oh, it makes me feel nervous. No, that's a terrible way to calculate risk. And there are better ways. So that's the next skill that I would say is really, really important. And you know, maybe if you're going to do especially AppSec or software security, learn the computer science behind how this whole thing, why we have bugs and why we can't get rid of them all. I'm not going to go into that now, but if you want to come to my RSAC presentation in June, I'm going to go into that a little bit more, but I'm not going to go into it now. But learn a little computer science about the nature of what we can prove in algorithms and implementations and what we cannot prove. This is really important, because it'll change the way you see, or at least it's changed the way I look at the problem fundamentally. Is understanding that computer science. That doesn't mean you have to actually go and prove the Turing proof. Leave that for the mathematicians, unless you're a mathematician, in which they have a blast. I'm not, but still learn some computer science around that stuff. That will help. In Secrets of a Cybersecurity Architect, I actually listed all the skills I bring to security architecture, and it's an entire page of 4 columns. Because I might have to do something about, I might have to understand something about networks and network defenses. I might have to understand something totally orthogonal, which is memory and how memory works and how operating systems load programs and unload them. So there's a lot of computer science here that when you dig into, it's important to really come to some comfort with it. Technically, if you want to be a technical, you know, if you want to be a technical leader, at least learn your area really, really well. And you probably want to broaden it out. That page, I don't want to reproduce it here, but you know, it's just about everything in computer science has come to bear, except logic gates. And literally in this class I'm teaching, I walked in and I said, almost everything you're going to learn in the CPU architecture is stuff I've used, except logic gates. I learned those 40 years ago, and I've never used that since. Logic, yes, but logic gates, no. But everything else in this class has come in sometime, maybe more than my career. So a little computer science really helps here. I'll just say, technically. Because how do you understand a heap overflow unless you understand how heaps and what heaps are?
Yeah. No, I agree. So can I quote you that says every CISO should learn how to threat model?
Yes, absolutely.
Cool.
I
All
believe
right.
so deeply.
I just tweeted that. Cool. All right, man.
I'll buy the t-shirt.
Because I agree with that, right? And I get in trouble when I say, look, you have to be technical. You have to understand these concepts, when at a certain level, because it will make you a better professional. And even if you don't go to the weeds, but you need to understand some of these things. So yeah, good. I agree with you completely.
So one other thing, if you're going to be a security architect, I mean, there's a lot of stuff that will come into play depending upon the context. But I will say that you're going to be, what we bring to the table, our special sauce is attacks and defenses. And it's really important to know that attacks and defenses, in a few cases, it's one-to-one, but mostly it's M-to-N or many-to-many relationship. So you're putting together a bunch of defenses that each one sort of adds to the pile of mitigation and prevention and reaction for every type of attack. And that's a kind of an art, but luckily MITRE with attack, ATT ampersand CK, and the ontology that then goes to defend, D, free, FEND, is a fantastic tool. If you're curious and you've got an attack and you want to know, well, what are the right defenses, just follow the ontology and it'll take you to the right defenses. Or I've got these defenses, what do they protect me against? You can work backwards. And I think that's a tool I wish I had 20 years ago, but at least we have it now, and it's a fantastic tool. So I will point out that for those of us who are defenders, being literate with the appropriate attacks and defenses to the technologies and architectures that we are working with is a critical piece of work you have to do.
Yeah, cool. I agree. All right, Izar, take it. Thanks for answering. Brook.
Thank you. That actually answered part of what I was going to ask. So let's go to the third question, which is going to be especially interesting. How do you stay sane? We have to do context switching a lot in between the different things that we work every day. We have to talk to people who are not so receiving of the messages that we have to bring sometimes. You have to calculate risk and look at how things break and sometimes see very important things breaking in very horrible ways. How do you stay sane?
Well, that presumes I am sane. So let's start there. Whoa. And, it's something I learned as an activist, actually, in my little short 3 years as an activist. And that was, you have to take, there's a famous activist song, and it goes something like, step by step, the longest march can be won, can be won. And that's it. We take what steps we can. And I take great I'm going to say joy, gratitude. Those are part of it, but those aren't quite the right words. I try to focus and take a little breath every time something goes right. Every time we get something like the threat modeling manifesto, or that threat modeling workbook that we did for Safe Code, and it comes out, I think, okay, we've taken a step. We've taken a step in the right direction. Now, what's the next thing to do? So I'm constantly thinking forward. And if I have any sanity at all, which is debatable, it would be because I stay focused on the task moving forward. And I try not to let the inevitable mistakes, they say wisdom comes from experience, and experience comes from making lots of mistakes. So if I have any wisdom at all to offer, I have made some bloopers, some whoppers in my life, lots of them. The most important words for any leader are, I'm sorry, I was wrong. If you don't know those 5 words and you cough every time you try to say them, that's time to think about that. But still, I've made lots of mistakes, and they're inevitable. And because of that, I try not to let those get into my taking the next step, because we got to keep taking the step. What we're doing here, again, is really important. People are counting on their banks to have the right ones and zeros that say they have some resources so that they can go buy food and pay their rent. You're on mute, Izar.
We are at 40 minutes. We probably won't be able to go through all the questions that we have. So, Brook, where do you prefer people to find you if they have more questions?
I'm on LinkedIn. Now, I will say, if you just send me an invite and you don't tell me you were attending one of these Open Security Summit or give me some clue, I'm going to ignore you, because I don't have time to research every single person. And I am willing to bet that a fair number of nation state trolls, because I'm kind of in the public view, send me invites on a regular basis. And no, I don't want to buy your product. And no, talent people, you can't use my network so that you control it. To find, you just ask me straight up, rather, because I know a lot of people.
Awesome.
And so, you know, other people have much bigger networks than I do, but I curate mine. But if you say Open Security Summit, absolutely. So with that, LinkedIn is a great place to find me. My DMs on Twitter are open. And, you know, when I get a Russian bride, I just ignore it. Some people like to play with those, but I just ignore it. So DM me. Be nice, please. I'm fragile, just like everybody else. Yeah, that's another place. And I'm pretty easy to find. It turns out.
Perfect. So the next question that we have is a bit more practical, but I'm sure it's going to be an interesting answer. Which step of the SDLC do you find most interesting, and why?
Well, now that's a great question. And I was looking at these beforehand and going, when I roll back many years ago, as I was starting doing security, which by the way was a complete accident. Somebody at work asked me to do the access control list on our internet router. And that's how I got started in security. And I think it was like 1997 or 1998. Okay, so I'm doing this stuff. And I'm also the chief designer at this little software house where I was the chief designer, chief design person or architect, you would call them today. And then I got into security architecture, and I literally have given the last 20 some years of my life to the practice of security architecture. Whether that's a worthy pursuit or not, good question. But I have given my life to that, and I am very passionate about it. Security architecture relies on threat modeling, to come back to Denise's lovely comment and question there. But nevertheless, I've really focused on that and design. Why? It's not really more important than anything else in the SDL. The problem with the SDL is that this current state of the art, every one of these things is not enough. Everyone is essentially incomplete, insufficient, or even broken in some ways. Everything we do. And once I accepted that fact, it became a lot easier to think about SDL. So there's no panaceas, but I'm fascinated by design, and maybe that's just because I have a very strong right brain, which is pattern oriented, and that's easy for me. So it's a place where I feel very confident and can run into it. But that doesn't mean it's more important. It's a piece of the puzzle, but it's my piece of the puzzle, and I'll own it and I'll take it and try to go as far as I can. So that's my thing, but that doesn't mean it's more important. In fact, and I think you might have been the one who said this to me, Izar, maybe, without testing, you cannot prove a threat model. The threat model is proved by the tests we run. And so it doesn't stand alone. It's not a standalone beastie. It gets revised because the static analysis shows that maybe you didn't think through the right coding things in your SDL, and the dynamic analysis, if you're doing web stuff, shows that maybe you didn't think through some of the design choices in your APIs, and then if you can afford pen testing, maybe it runs down all the things you think you're protecting, and 2 or 3 of them you're not protecting them as well as you thought you were, or your authorization mechanism doesn't work the way you thought it did. All of those then feed back to your threat model and make it better. And so, yeah, so it doesn't stand alone. Even though I'm fascinated with the design piece of this, it's not more important than anything else. It is as important.
Very nice, very nice, very nice. Okay, the next one that we have. And now we get really, really into the weeds. How to take into account secure design in low resource environments.
Dang, this is a great question. And I love looking at these questions and going, somebody's asking the right questions.
Yep.
So one of the problems is people like me are really expensive. People like Izar, people like Denis, I think that's how you pronounce your name, isn't it? Denis.
Dennis is fine.
Dennis, okay, Dennis. All right, sorry. My high school French is taking over here. But it's hard to get people like an Izar. And they're few and far between, and it doesn't scale. So there's a few things you can do. I like to say, if you're not doing any threat modeling today and you've designed a big product or a complex product, you have found zero. You've done the best design choices for whatever reasons you've made. But if you find one thing that you mitigate, you're better off than you were tomorrow, than you were yesterday. So, just getting started is good. There are some wonderful automation tools that have matured over the last, since I wrote Securing Systems. In that book, in the afterword, I said, hey, there's a threat modeling automation thing. I've looked at it. It's pretty darn good. Well, there are a few now. And, that's a piece of the puzzle. And they have some community versions, so that can help. There's threat modeling tool from Microsoft. It's very noisy and it's app-centric, but it'll get you started. It'll tell you some things. Those are very, very, they're the community versions of the threat modeling tools, the commercial ones and TMT. They'll get you started. There are 4 or 5, 6 really good books on threat modeling, not the Stride book. I talked to Frank Swiderski for quite a long time, and it should be, you can read it, but it's a bit obsolete now. But Adams is brilliant. Izar's is brilliant. If you want, a risk-based thing, the Pasta book is, very interesting. There's some really good stuff out there that'll help you in learning how to do this. I'm not going to, push my own books on you, but I've written a few on this subject. And so all of those things can help, and just kind of get started. Take a step in the water and do what you know. One of the problems I see in software security is that it's hard to hold the entire universe of it. So you're going to do what you do. Time and time again with my clients, I find they have done a few things really well, a couple of things not so well, and missed a whole bunch of stuff because they did what they knew. And so that's one of the pieces, and I don't quite know how to. I mean, I keep getting up on stages and saying this is what software security involves, but I'm just one person, so that doesn't scale very well, and I'm not quite sure what to do about that for you. But I would say, you know, just get in there and use some of the tools and see what you get, and maybe in a low resource environment, you could, you know, get a free hour with one of the consultancies, the software security consultancies that gives a free hour, or do some stuff like that. That sort of thing is starting to happen a little bit. And so that might get you along, you know, get you pointed in the right direction. There's a bunch of stuff you can do even with very, very low resources. One of the things about startups is you got to put revenue on the table, and everything else is subservient to that. So just don't talk to somebody who comes in and says security is the most important thing. Whoever you talk to, if you talk to anyone, make sure they understand that startups have to get a product out the door and start selling it. I'll end with that. That's really important. They got to be on your side. But yeah, I think there's some stuff you can do, and that stuff's been available for a while. There's some wonderful stuff at OWASP if you're doing web stuff. If you're not doing web stuff, at least maybe take a look at the thing that Izar and I and a few other people wrote for SafeCode. You know, there's some great resources out there.
Nice. Okay. So we're getting to our final 10 minutes here. Yes, we will not be able to get to all the questions that we have. But the next one is, how does threat modeling fit into risk assessment? And I can't think of anybody better to answer this than you.
Well, a risk assessment is just a threat model without doing anything about it. It's really a threat model. I mean, so years ago at Cisco, when we were designing our SDL, and I was Cisco InfoSec's first application security architect. So I just want to say I've been doing this for a while. Whether I've been doing it well again or not is another question, but I've been doing it for a while. And we had lots of things. We had architecture risk assessment, we had risk assessment, we had architecture review, we had all these bloody steps. Well, when I was Intel security was my job, but 25% of my time was on software security at Intel. As their equivalent of a distinguished engineer. They call them principal engineers. It's protected. It's you got to go in front of a jury and prove your leadership and all this other stuff before you get that title. So it's essentially the same thing as distinguished engineer. So there were all these other distinguished engineers on this panel, and we had all these steps. They had a very typical old-fashioned SDL, very waterfall, and all these different steps. But what blew my mind as the participant observer is it was clear we were all threat modeling every time, just at really different levels. And so I jettisoned all these confusing things, like what is a risk assessment? What is architecture review? What is architecture risk assessment? What is architecture security architecture review? I mean, so many names, so many gates, so confusing. Can we just call them threat modeling and doing it at different levels? And for different, slightly different products. And so I've jettisoned all that stuff. I've thrown it all away, and I just say threat modeling. Risk assessment, if you're going so far as to figure out what threats and what their risks are, you're 2/3 of the way to a threat model. Now figure out what to do about it, and you've got a full threat model. Boom. Are we done?
Actually, I think I'm wrong. I think that we have 2 hours, right?
Yeah, we have 2 hours.
Oh, cool. Yeah, I thought we had only one. Yay. Okay. So
yeah, you've got plenty of time. Don't worry about it.
yay. So we will be able to get through everything. Brook, now the 1 million question. How do we scale?
This is
it's not focused.
Yeah, no, this is the question, isn't it, Izar and Dennis? I mean, we deal with this every day, all day long. How do we scale? You know, Gary McGraw said something, and it was so true. He said, for years, the way you train security architects is they follow somebody around and they, you shadow somebody. And you know what? There are a bunch of reasons that's a lousy way to do this. I mean, it's okay. If you can follow someone around and learn from them, great. What if you hate Brook or you hate Izar? You're not going to learn anything. And Dennis is so likable that no one would ever. No, I'm just kidding. But I mean, there's all the personal stuff, and so it doesn't scale because how many people can follow you around, right? And so literally that doesn't scale. And things like the movement of a lot of our tools into CI/CD pipelines and a DevOps mindset is a start. It really is a start. That's great. And I want to see a lot more of that. What I'd love to see is someone to crack this problem. And I am talking to a couple of companies that are trying, by the way, but I'm not going to name them because I'm not convinced yet. But I want to see a product that can gather the architecture automatically by listening to the network, by going to the stack and looking at it, the technology stack, by watching the interactions, maybe with an agent, and putting all that stuff together and coming up and giving the architecture, the actual as-is architecture as a starting point. Then I'd like to see that fed into these wonderful commercial tools that are really maturing. And I'm friends with both of them, so I am not going to play favorites here. And all three of them, actually. So, I'm not going to play favorites. I think they each have their strengths and weaknesses. That's a different conversation. But I'm super excited about that. Wouldn't it be great if then that information was fed into the tool and it spit back the most important? We just spent 2 hours playing with Wardley maps and seeing that if you started mapping, you could come up with the most important things to do and the ones you could let go if you have the right axes on your map. I'm really excited about
When you
that.
say that, wouldn't it be great to go to a provider and get a Wardley map of the current situation?
That's
right?
what I'm saying. That's what I'm
Uh-huh.
saying, Dennis. Wouldn't that be amazing? I mean, and you got that Wardley map and the risk. I mean, you could say risk, but think about a report. When I do a report for my clients, sure, I put the high risk things up front, but it's a long bunch of tables with mitigations, and oh my God, it's hard to read.
But you know what's really exciting? And I have to say that I look at this summit, and one of the themes that exists here is almost the solution that is actually to your problem. Because if you look at some of the sessions from the Starbase guys, from lessons learned from creating diagrams as code, security as code, right? C4 threat models, which C4 is a great architecture, basically open security test control at scale. Like a lot of these, and like using runtime code execution to map code security, all of these are now basically they're people that are thinking about how do I extract architecture, how do I extract information, actually how to create a graph out of the data so that then we can analyze it. And I think that's the foundation that was missing. What was missing was these graphs that come out of our infrastructure in a way that we can then put them together, right? And that thing leads to the world that you're talking about, but we need that foundation to be there, that when the source code change, when you ship something, when you modify something, then your graph changes.
Yeah, and it has to be dynamic, and it has to be the problem with threat modeling too often is not only is it hand done, manual, and let me tell you, years ago, Archie Agrawal came to me. I mean, we were on the GWeb certification for GIAC, for SANS Institute GIAC, and we helped build that. Okay, me and Archie Agrawal, who's the guy who runs Threat Modeler. I know this is serious risk. I don't mean to, again, I don't play favorites, but Archie was working on Threat Modeler at the time, and so he showed me his beta version, and I was like, yeah, this is where things need to go. But imagine if either of these wonderful tools, if you could pull in today it's all very hand. What I was going to say is he came to me at McAfee, and my 125 security architects didn't want to do it because they wanted to learn to threat model by hand. And while that was great because we made threat modeling part of our SDL, it was just part of the woodwork. And that's a whole long story, which I described in the Secrets book. But nevertheless, that was a huge success. And it proved to me it can be done at scale with 5,000 developers. Still, it was very hand oriented. Imagine if you had the architecture in real time, and in real time, you could look at what the changes. If you did a cycle of changes, you could look, how have we changed things? Just what Dennis was just saying. And I'm like, wow. I haven't seen it yet, but I want to see it.
But here's
Can
the thing
we
that I found
encourage the
sometimes,
vendors here
yeah,
to take the steps?
yeah. But the other thing I found amazing is how, and I hope you don't view this as a criticism of what you just said, but if I had 150 people doing something, I would spend 10% of that time automating it. Because even if you have 30 people, 20 people doing something by hand, actually building technology to automate some of those steps is already more cost effective, because with time it becomes more and more and more automated. But I see so many people sometimes have huge teams, huge stuff, and I think, wow, with a tenth of that, if you just spent in making your guys more productive, thinking about
I tried, believe me, I tried, and they just, so one of the problems there, and this is a little unfair to those 120 people. So let's really be clear here. McAfee in the old days bought 250 approximately companies, and its culture wasn't very nice. This is before I got there. Its culture wasn't very nice. If you poked your head up and said, I think there's a problem somewhere, people would shoot you. So people learn to be, stay in their foxholes and keep their heads down because they don't want to get shot. And it was very much a company of your product, we want you to make these sales money, and we'll talk a lot about architecture, but really that's kind of some kind of prettiness on the top, and you keep in your product and you make it work, and you make your dollars. And that was the company. They were trying to change that by the time I got there, to be fair. The leadership were really keen on that. But a culture like that is very hard to change when you have a lot of long-term people who remember that if they stuck their heads up and said problem and they got shot, who have long memories. Yeah. And so one of the things that happened is, I had just about every kind of SDLC, software development lifecycle you can imagine, from strictly waterfall to wildly fast, agile, extreme programming kind of thing. I had every different static analyzer on the market, many of which were doing nothing. And, like I had one team that had 72,000 findings. Guess how many they fixed? 0 would be correct. And the 46,000 one, we fixed those, by the way. We got those going. That was prime on my list of things to fix. So with all of these people with their different ways of doing things, one of the things that's the Brook style that you may not agree with, and that's okay, because I think this is aesthetic. But when I go in and I see a team, even though the company is Coverity, and they've got Fortify, and they're one of the most successful static programs, analysis programs in the company, I'm not going to go in and say to them, the corporate thing is Coverity. I'm going to say, if anybody else wants to use Fortify, can you be a resource for them? Yeah. Right? I'm not going to disturb that which is working well. I am not going to go and disturb that which is working well. So if I have a team that's written its own fuzzers, I'm going to say, hey, they're fuzzing. You see, this is really cool. Rather than, oh, you got to use the corporate fuzzer. No, I'm not going to do that. I'm going to build on what's successful. And so to be fair to the people who were there were a lot of different ways of doing things. And automating was always a choice of how much disruption you were going to make. And so that was kind of a problem that I struggled with and juggled constantly, just to be fair to those folks. But they certainly weren't interested in looking at early threat modeling tools. They wanted to learn to do it. And that was an interesting artifact, perhaps, of the situation. Let's leave it at that. Because I completely agree with you, Dennis. I completely agree with you. If I have a problem and it's being done by manual everywhere, the first thing I'm going to look at is what can we automate here? And since that time, there have been a bunch of different things that have happened, open source things. Like there's this great tool. It hasn't got a lot of notice, but, and I forget what it's called, but what it does is it just, if you use one of the graphics programming languages and do your graphics in that, if they change, it'll just find that and say, hey, you need a threat modeling session, that's just one really great step. Just knowing that you can spin off a ticket for a threat modeling session because your architecture obviously changed. That's cool. There's a lot of really cool technology out of there that can automate just little bits. If we can't automate the whole thing, we can automate bits and pieces. That's great. Completely agree, actually, violently agree. And that's why I wanted to talk about McAfee and be a little fairer to them, because it wasn't like we had one build system. We had 50.
I know. There's a certain size of company that when you ask, what do you have? They go, everything, everything. You can throw a dart to a massive technology thing, and they have acquired a company, they have grown through acquisition, and that thing will be in there somewhere. Whatever language you talk about, whatever system you talk, if it was built in the last 20 years or 30 years, they're going to have one running in the company.
Well, here's a question that nobody asked so far that's really maybe interesting is, one of my maxims is the longer a company has been building software, the more they will have stuff that was built for a different threat landscape. Threat landscape. So that's another thing, answering the question, what addition of competencies or capabilities? I forgot to mention, you got to stay up on the threat landscape. What are people doing today and what are they interested in? And it just grows. It grows. Old exploits never die. They just wait until you're not paying attention. And so, but you need to stay on top of that. And what we were worried about in 2003 is not what we're worried about in 2022, I can assure you. And so, if you have stuff that was written in 2003, their thinking about the threat landscape was radically different, and it is probably insufficient. So your legacy problem is not just one of a bunch of vulnerabilities. Yeah, that's true. But it's also it's a design problem. All that stuff was written when they didn't have Frida to take apart your code.
Man, there's a great screenshot once I saw from a guy from Microsoft that showed a picture, and I think it was, Windows 95 or Windows 98, but it was like save function because it had a try catch and it was a massive buffer overflow. But at the time, that was the idea of secure, right? You handle your exceptions. Nobody understood buffer overflows. And it was, massive string copy, insane penalty buffer overflow exploit. But at the time, that was the understanding, right?
Yeah, I mean, well, and old Windows, one of my favorite people, the other chief designer at this little software house, Inisys, with me, Stephen Malinowski, who is also a brilliant composer and pianist, and that's what he does today. But at the time, we were chief designers there, and Stephen used to call Windows, this is before the NT model, which is actually designed. He used to call it the collection of necessities. It's not an operating system, it's a collection of necessities. Imagine an operating system where your device driver can touch every part of the operating system in memory. Yeah. Whoa, that's a really different threat landscape. Yeah. And that's why that doesn't exist anymore. So, I mean, Microsoft just got tired of dealing with people's badly written device drivers. So they created the NT device driver model, which is wicked hard to write to. And that's on purpose.
Right.
And you might see, as Dennis and I exchange things, the wealth of things that we've had to dig into from a computer science perspective in order to do this job. And that's what I was about before.
Yeah.
You know, broaden your technical capabilities and keep broadening them. Because I mean, you know, understanding operating systems, understanding device driver models. If you get a device driver issue, you got to understand how that operating system deals with them.
Yeah, but the best way to learn, man, is to hack, right? Like some of the best learnings I've done was when somebody said, "Hey, can you do a review of this application or this language?" And I go, "Of course." Go to Amazon, buy 2 books on it, read about it, and then go, "Cool." And but you know, reading code, learning architectures, like, you know, I remember trying to write a Windows kernel driver. You know, I learned so much about Windows kernel that just there. Right? So doing hacking,
All the
writing
mistakes
code
you make,
is the
all
best
the
thing.
bugs you put in there, right? And it wouldn't run. Exactly.
Yeah, yeah. Never had so many blue screens of death, man, than trying to write. I did a project once, man. I was paid to do reverse engineer copy protection systems, because these guys kept being, you know, it was at the time where there was lots of piracy, right? So they would send me a version, and I would send them a version back to say, "This is what the guys are doing to you." And it was fascinating to see how, you know, that was a big lesson for me, because there was a time where the only version that was just about secure, well, it was still, I could still find a way around it, but it slowed down something so dramatically, and it bloated everything. I'm going, look, this is not realistic, right? Like, this is, you might be a bit more secure, but, you know, this is, you know, you don't have a product right now. So, you know, but that's how you learn, man. That's the best thing to learn.
It is. I mean, I wouldn't be half the engineer if I didn't write that, if I didn't try to bring that IR driver into Windows and get it running, and realize that the clock function was time running backwards. And by the way, infrared is really sensitive to time. You can't have the clock run backwards. It won't work. And I think I spent on that bug probably 6 weeks. And my technique was, I put on my virtual lab coat, bring up my virtual clipboard, and just start writing data. Well, this. And then invariably, I get so caught, just so overwhelmed. I go for a walk, and about 3/4 of the way through the walk, I go, "Oh, try this." And dang, if that isn't the answer. So, you know, our minds work sometimes when we don't think they're working, or when we take them off. So that's an important part of my process.
Yeah.
But yeah, I mean, all of those mistakes, all of those bug chasings, all of the null pointers I've written into code badly, all of those things have made me a much better technician.
Yeah.
Frank.
Actually, you know what? One of the things that I don't think I've heard mentioned recently, but a great way to learn, especially as you get more experience, is actually threat modeling. I remember doing threat modeling sessions where, you know, in the beginning, when they tell about how it works, right? Now, this is how it works. I remember having these sessions, for example, on open, you know, what's that, open API, that, you know, the new Kubernetes stacks, right? And I remember having these sessions where, like, for almost the first couple of hours, I was thinking, wow, I'm getting a masterclass on how this thing works, and I'm actually getting paid here because I'm actually learning so much. But also, you know, of course, that then you start to learn, and the questions are always going to be the same. How do you authenticate? How do you validate? How do you do this? But doing threat modeling and learning code is actually, if you can social engineer well the session, you learn a lot. And everybody learns a lot, because it's a great way to explain how things work. And if you get a subject matter expert to explain it, then you learn a lot about these architectures, about these systems, about what's possible. You know, first time I saw Go was on a code review and architecture review. I was like, all right, cool. So that's how it works. It's like, so it's a great way to learn too. And actually, going to the point, that's how you scale. You scale because you're learning all the time. And then
Well,
if you never stop learning, then the jump is never too great.
right. Well, and that's it. I mean, I wrote a lot about this in Secrets, and not that I'm trying to sell books or nothing or anything. I only get $3 anyway, so the book is like $60, and I get $2 or $3. It's because I get 10% of the wholesale, right? So it's not a lot of money, but so don't write these kind of technical books because you want to think you're going to make millions, because you're not, or at least mine don't make that kind of money. But nevertheless, I did write about this sort of there's another piece here, and you touched on it, and it's really important, which is why I'm really inclusive, especially in things like design and the arty things in the SDL. I'm really inclusive because Izar and I have talked about this like probably 50 times in the last 5 years. You're sitting in some thing and they're explaining the architecture to you, the lead architect, and one of the developers says, yeah, but that's not how it works. And they start arguing, and you facilitate them a little bit to stop arguing, and then the developer goes up and says, this is how it works. And the architect didn't know that it got changed in the iterations, right? And so the knowledge gets shared. This is one of the greatest things about threat modeling sessions, is if you are really inclusive, instead of just the security person and the lead architect, the knowledge sharing that goes on for everybody in the room is powerful. And the other thing that's really interesting about it is I cannot count on my fingers and toes the number of times that someone really fairly junior has said, yeah, but don't we have the SSH port still open in the operating system with its default password? That's an actual real instance that actually happened. We were reviewing a threat model.
Yeah.
I was I was traveling to a global center. I won't name where because, protect the people. But nevertheless, we're sitting there and it looked like a great threat model, and it was all they'd really thought through. And this, fairly junior person says, yeah, but the SSH port is open with its default password. And they were about to ship this thing.
Yeah.
If you're not inclusive, you're liable to miss junk, and it's liable to be really dangerous. Be inclusive, because what you said, Dennis, what you said about sharing and knowledge transfer, but also somebody might know something really important you're not seeing. I'm finishing this major threat model for a customer of which we are charging a lot of money, and I realized I hadn't asked about protecting the passwords to the admin port. I've gotten so down deep into all these other things. I've got all my attacks all wired and my mitigations, and I'm typing away and building all this stuff and building charts, not Wardley maps. Wardley maps are joining my report, believe me. But I'm looking away at this thing and realized I didn't ask them about the passwords for that admin interface. Oops.
Right, Izar, next question, man.
Okay, for the next question. The good thing with Brook is that you start on a very simple question, how to scale. And then you end up on a completely different tangent with a lot of things to learn. But that's, a beer with Brook. Okay, the next one is how to compose and reuse threat models.
We're working on this. The 3 people that have been talking on this thing are all working on this problem. I just want to say, stay tuned. But one thing that's really important, and this was true at Intel, and it drove me nuts. I just want to tell you, people, some little component, and they do their threat model, and they'd say, well, we're done. We're not going to re-threat model. Problem is, threat models involve dependencies. And every time you change the structure or the flows, you're likely to be shifting, not always, but a lot of the time you're shifting the threat model. And different component teams will make different security assumptions. So threat models are not additive. You can't just sum them up and say we're done. That is the first thing about this. So when we talk about reuse threat models, what are we talking about? One of the things you can't do is just say, well, we did the threat model for our little gateway and now look it up. Problem is the client might have totally different threat model assumptions about what they're going to take care of and what they're not. So one of the things I like to talk about, and I'm the only one I know who says this, so take that for maybe it's aesthetic, but I like to talk about a security contract. Obviously, when you build a gateway, you're not going to handle everything, but it's really important if you build a gateway to which there are downstream things behind you that you tell them what you've taken care of for security and what you haven't. Because if you've taken care of all the protocol and authentication and authorization, but you have not looked into the message, attacks might be in those messages, and you need to tell downstream that the message is untouched and might contain evil, and you have to do something about it. Otherwise, the downstream person might say, well, the gateway takes care of security, so I won't do anything. Boom, you've just now allowed the attacker to get an attack into your downstream thing. And you don't want to do that. So it's really important when we put things together that we are really clear about what our assumptions are, what security we're taking care of, and what security we haven't. So I'd like to see, just like a bill of materials, a security assumptions contract. I like to call it a contract because it's with anybody else you're communicating with. I'd like to see that. Maybe I'm going to throw that idea out, and I did throw it out in a couple of books, but I'd like to see that get more use and thought. Okay, so that's part of the composing. Obviously, we've talked about a whole bunch of stuff around technology. Can I hand it to you, Izar, and have you tell people about PyTM? Because that's one of the most exciting things that's happened.
Actually, I don't think the PyTM itself. I think that the whole new scene of threat modeling tools is bringing down to that. One thing that we are seeing now, and as you noted before, the Microsoft Threat Modeler, which was for a long time the threat modeling tool out there, especially because it's free, it was extremely focused on Windows apps for obvious reasons. Lately, has been extending to Azure and all that good stuff. But still very Microsoft centered, very let's do this threat model here thing. And now what we're seeing is many threat modeling tools are adding the capability of importing prior threat models or modularizing threat models and saying, hey, if you want to zoom on this specific thing, let me link to the threat model of that specific thing, and you can jump between them. So we are starting to, I think that the threat modeling tools industry, in quotes, because a lot of the effort is open source, of course, is stopping. It's not looking at threat models as pages, and it's looking at them more like books with self-reference in between the pages. So we are starting to see jumps between 30,000 feet and close to the ground, much more easy and much more useful. And that's going to, I think, lead to what Louis is saying on the chat. He says that he thinks more about architecture patterns that lead to common controls and inheritance. And that's exactly what it is. As soon as you can jump in between different levels and different components of threat models, then you can start seeing, hey, that control that I use in there actually gets inherited by this threat model and mitigates that specific thing. And we can talk about languages of things mitigating each other. And you don't have to mitigate every single thing on the place where it happens.
So I'm going to say a couple of things. This is all in addition to what Izar just said. Very exciting. What we need are some common patterns. And the best start I know of is the continuous threat modeling checklist. This is a very powerful resource. It takes a design-centric, not threat-centric. You have this sort of problem. These are the sorts of things you're going to need to do in order to design securely. That should be turned into a book of common patterns. And I have said that for many, many, many years. I've suggested it to Izar. I've suggested it to lots of other people.
I agree. I vote for that.
I don't want to write that book. I really don't. It's not the way my brain works. But I wish someone would write that book. But in the meantime, jump over to the continuous threat modeling checklist. And by the way, the continuous threat modeling project, if I could just have a little personal moment here.
Here it
My,
comes.
my daughter worked on that, and she's one of the authors. Yes, my daughter works in security architecture, and she's a fabulous security architect, and I'm way
Yes,
proud of
she
her.
is.
And I work her into every one of these presentations. See, I did it.
And as someone who has worked very, very closely with her, I have to say that Alison, much like her father, does take InfoSec to a very nice and personal place, and she's becoming, much like her father, a very talented InfoSec architect. And this actually gives us a segue into the next question that we have here.
Can I just say one other thing? Sorry, Izar. Let's talk about revise, because that's not up here, but reuse is kind of leads into the revise. If you're doing your threat modeling once, I want to tell you, I believe you are doing it wrong. I really believe you're doing it wrong.
The next question is how to develop security patterns. So let's jump into that, and you can go into the design and revise.
Right. Well, design and revise. That's it. Exactly there. So the way I've seen this work, again, the continuous threat modeling, there's a series of design patterns. It's not all of them. It's sort of web-centric and that sort of thing. But man, that's a start. That's a really great start. So I want to point you to that. There are patterns there. And there's some other patterns. The Safe Code folks put out a bunch of security stories, agile security stories. That's not a bad place to go and look too for patterns. Yeah, Luis says, yeah. There's some good stuff happening on the chat. So I go look, and there's a lot of really smart people on this call, and they're not all talking, but that's okay. How do you develop security patterns? You'll see them. I think they actually emerge. So when you're like, somebody said, you know, low resource or first starting, some of those places, you go to the standard patterns and you can look and you can see something like, you know, how do we prevent certain kinds of, around secure coding and preventing certain kinds of vulnerabilities. There's a lot written around, especially in the web space. OWASP is a great source of help. And those are security patterns too, by the way. There's the continuous threat modeling checklist, which is fabulous in my opinion. There's a bunch of stuff written out there that you can get. And as you do things, you'll start to do them certain ways. When you do them 3 times, it's a pattern. If you document that, rather than writing all the patterns that the universe needs to have for a particular team or group or product or whatever, let them emerge. That's kind of how I've seen it work. And yeah, that seems sort of arty, and maybe I am arty, but I just want to say I've seen that work really well. When people try to document all the right patterns, those I've seen fail and founder really badly. But if you just start writing down the stuff that seems to be working and it's the way we want to do things, you'll build a library of patterns. Over in 2 years, you'll be surprised what you have. But it just takes a little time. Yeah. And you know, Izar or Dennis, do you want to add to that?
Actually, we are going into the next question, which is what are good resources to learn to develop security patterns? But Brook, actually, I wanted to take a step back in here and look at this security patterns thing, not from the point of view of design and threat modeling, but give us, what do you see as security patterns in terms of the things that you should use as a habit, as a pattern, as a security architect, as a security practitioner? And how would you like leave the pattern from the design patterns realm that we like so much and that we talk about so much, and bring it up in the stack, so to say?
That's interesting. That's an interesting question. I'm not sure I have the best answer for that because I've been at this for a while, and so they're kind of in my brain. One of the things that Probably the best thing that ever got me to understand what security actually is was reading Bruce Schneier's Secrets and Lies. So I'm going to start there. You have to understand, what am I trying to do? And I didn't have a good idea. I'll never forget the first time I did a security architecture review at Cisco. I was shadowing at the time Laura Lindsay, and we came out, and Laura looked at me and said, "Brook, we're not the cops." That was really powerful, and it stuck with me. And thank you, Laura. And that's important. So you know, you gotta know at what space you're working in and how you're working. But I'll tell you, reading Secrets and Lies helped me understand first, what is it I'm trying to do, and to avoid security theater. And that book has a lot of security theater in it. And I'm not going to go into the examples, but I'll just tell you that that book changed my ability to be a security person. So understanding where we're going. And then I'm going to say, working with all these really amazing and very skilled enterprise architects at Cisco helped me become a better architect. I mean, I was a designer, an architect before I got there, which is one of the reasons they hired me, because there were very few architects going into security in those days. And so they grabbed me because I had lots of design background, which lots of people did not at the time. And so, you know, that was sort of what I brought to their mix. But working with these world-class enterprise architects taught me some rigor. And one of the things you have to understand, at least I have to understand, in order to design something, is where I'm going. It's not just about patterns. I want to know, what are the behaviors? What does secure look like? What does that look like? And so, you know, I've offered my 5 security behaviors, principles, things for people to do, but just, you know, at a more macro level, understand what it is you're trying to do. And then you'll see the patterns that emerge. One of the things that happens to people as they work on, and not everyone, and some people are preternaturally skilled, but for us mere mortals, and I include myself in that category, looking at really disparate problems and seeing the similarities in problems and the similarity in solutions across a lot of disparate things is what develops ability to see patterns. And I've seen this time and time again. Again, I have literally worked with, trained, mentored hundreds of security architects. And time again, they teach me that looking at stuff you're not familiar with is probably the best teacher of all things. So one of the things I do when I set up a program is like threat modeling, which is a great place to look at security patterns, right? What I do is I get teams to invite 1 or 2 people who want to learn threat modeling, maybe they're the security champions, maybe the security architects, whatever you want to call them, from some other really disparate team that's working on something really different. Invite them to your threat modeling session. A, they might see something, you know, forest for the trees, and B, their ability to identify patterns will increase dramatically. And if I have skills in this area, it's because I've looked at every single type of software, every single major architecture of software, from global clouds to stuff living underneath operating systems, stuff in the boot sector, stuff, you know, stuff that's part of getting an operating system going, that's in the ROM. I've looked at all these different problems, and that begins to see where authentication is like a tool that can be useful to close attack surfaces, and also expose the problems with relying too heavily on authentication all by itself, right? And so both of those security patterns I see across many different types of things. So probably the best way to learn this is to look at problems that crack your head. Dennis said it a little while ago. He was talking about hacking stuff he'd never seen before and all that it teaches him. Yeah, and that's what I'm talking about, is getting into places. So if you have large disparate teams at scale, going back to the scales question, one of the best ways you can help everyone become better is to have them look at stuff they're unfamiliar with instead of always looking just at their own stuff. Cross breed, get people in there across the way. And I've done this at scale with 5,000 developers, and it's magic, frankly.
Nice, indeed, nice. Now,
Actually,
okay,
George, I want to add just a little thing here on great resources. One of the best resources out there is OWASP. If you look at the materials, the guides, even just learning, even just, although a lot of stuff in OWASP is about, some of the security patterns and issues, it'll definitely look at ASVS, because if you look at some great security patterns, the application security verification standard is full of patterns. I think it could be expanded to even create patterns, but the kind of, you're doing this, you're thinking like this, you're mapping like this, is definitely a great source. Although I do agree that we need a decent book just on patterns, because and mapping a threat modeling, because a threat model that represents a good architecture is actually a good pattern.
So let me take a small jump into that. Brook was very gracious, and he mentioned the continuous threat modeling handbook. I would sort of add that it's not exactly about design, it's about principles. And the reason why I make that distinction is that today, if you want, for example, patterns of design for one of the big cloud providers, something, you go into the documentation, they have the stuff there. This is how you put a machine. This is how you put a load balancer in front of it. This is how you put a firewall. This is how you put a WAF in front of it, right? They have these patterns documented in there, and they have courses and they have certifications that will teach you to think in terms of those patterns. The problem is the people who are developing the next big thing, they don't have that documentation. They don't have those patterns. They can build on the idea of those patterns, but what they really need in order to create their own patterns that are going to be secure is the principles of security. And that's what we should be trying to teach them how to develop the sensitivity for, so that they can create those new patterns.
Yeah, okay, I would expand that to say what also they really need is reusable components that are secure by default. Because, and this is where you look at the worldly maps and you see, if you're innovating, you want to be commoditizing as much as you want. Basically, you want to be using as many commoditized components as you want, so you innovate on top. And the best way to be secure is not to keep reinventing the wheel. So if you are basically building a product or new thing, you should get a default setup. You should get a default environment to execute a code that is secure. You should get default authentication, authorization, monitoring, hardening, pick APIs that is very hard to write in secure code, and then then have patterns for the stuff they're customizing, which is custom build. But ideally, you want a mode where it's very hard to create security vulnerabilities or problems, because they're already living on top of these very well robust and mature components.
I don't know why, especially larger companies with more resources, don't invest more in vetted implementations. So Christoph Kern, years ago, remember, he was one of the authors of the 10 design flaws book, the founding member of Center for Secure Design. Christoph Kern had removed cross-site scripting from his part of Google, and it's because he invested in a library, and if you had inputs and you didn't call the library, he broke your build, and you had to go talk to him or his engineers and say, why are you not using a library? Is there some reason you don't like the library? Is there some reason you think you don't need it? And that, that I never want to say to somebody, you have to escape your inputs in your web stuff. Why do we have to keep saying that? We should have libraries that do it. And it's just as an example of what you're saying, Dennis, that we've got to have, we've got to use more vetted implementations. And if you have customers,
yeah, go on, sorry.
why are you repeating it? Why are you repeating? Why does everybody have?
I tell you one of the reasons why is because in most organizations, mid-level and large, ask this question: where is the department? Where is the team that is making the others more productive? Where is the team that their job in life is to make other teams better? And here's something that I'm more and more realizing is that in security, we made a massive paradigm shift in the last decades from being the department of no to be the department of, let me help you, let me enable, let me figure out a way. So let me provide you a service where we add value to you while allowing our objective, which is to be secure, to evolve. What I'm finding a lot is that there's not a lot of other departments in companies who do the same thing. And what ends up happening is that inefficiency is teams don't talk to each other. Teams don't collaborate. There's no reward for that collaboration. There's no allergic reaction to why do we have 10, 20, 30 versions of this? And actually, there's an amazing worldly maps that Simon talks about where he does multiple maps of multiple teams. Then he puts them together and you see a huge amount of repetition. You see a huge amount of variations in the same organization.
Yeah. And, you know, this is an area. So going back to the, what's in the years ahead, vetted implementations and rock solid technology upon, you know, components upon which our stuff is built. You know, I went to this great lecture and I can't remember the fella's name. Unfortunately, and so maybe this'll it was once one of those things that Zoe Braderman put together, and Zoe is just fantastic. And it was somebody who was advocating for writing special purposes languages for everything, basically, and doing the security as part of the language, and then you know you get to build your functionality without having to worry about security at all because it's built into the language. That's sort of the ultimate of what you're talking about, Dennis. I'm not sure it's the answer for all problems, but it's certainly something that we're looking more and more at. Swift is a heck of a lot better than C by factors of,
Rust. Why is Rust so powerful now, right? Why is people adopting Rust? Because Rust has a lot of the advantages of C++ without the memory management problem. You know, that's the key there. So I completely agree there. Right? And I feel that using those reusable components, and Jeff Williams used to talk this for a long time. You know, he had this idea of ISAPI, right? The Enterprise Security API, where you grab these components and you reuse them. And actually, this is an interesting thing because you can actually use security to force some of this because, and I've used this before, it's a bit passive aggressive, which is to say, hey, you guys can invent whatever you want, but here's what you already got with these modules. And if you want to do this, this is already the bar that you have to jump. So either you invent all of it or you reuse this model. And then they go, oh, all right, I didn't. And then you start to think about everything that is needed. And they go, actually, that module might be a little bit harder to use in the beginning, but it's going to save me so much time. I'll use it.
It's what Steve Atchison said to me in 2001, and a bunch of other people have tried to claim this, but Steve Atchison said it to me in 2001. I know this. He said, Brook, always make the easy path the secure path, right? Yeah. And that's a good dictum for us to always be thinking about. And to be fair, you know, I led web infrastructure and application security at Cisco for a bunch of years. And the infrastructure they had, this is pre-cloud, so it was billions, hundreds, thousand Java runtimes, all running on servers everywhere, because it was pre-cloud, pre-containers, you know, all the stuff we take for granted now for elasticity. That was the way they did it. But that infrastructure, interestingly, ran for at least 8 years without a major security incident, even though it got attacked 50,000 times a week. I just want to say, and those numbers are not made up numbers, by the way. And you can do this, but part of the strength of it was you either did it the way, exactly what you said, there was a path. And you take that path, and a lot of the stuff that you needed was commoditized, completely commoditized for you. Certainly things like authorization and authentication were completely commoditized. You basically flipped a bit in your config file and you got authentication, right? But if you didn't want to do it, you had to come and prove to everybody that your special unicorn really needed that, and you had to sign off a risk waiver, so you were on file, and go into the all dirty things network.
I know, but that works, man, and it's fair, right?
One of the problems that we had at Cisco was, and it was a big lesson for me, because I came from this tiny little company, about 20 programmers, right, where everybody was brilliant. I was the dumb guy in the room a lot of the time. Really brilliant, really great. Everyone, you could count on everyone. The most amazing tester, she was a great designer and programmer, and she's the woman who actually did the very first, put your card in and get fuel pump. I remember it sitting on her lab desk way back a long time ago. And Lucy McCoy, really brilliant people like that. And I was used to that. And I got to Cisco, where web developers were kind of a renewable resource. They would just hire a whole bunch of contractors. And it was this powerful lesson because, yeah, there were brilliant people and there were people who were way better than me, certainly. But there were a lot of learning Java in 21 days programmers too. And that was really hard for me. And I took a lot of hits from my colleagues about how I was writing documentation, how I was teaching, how I was interacting, because I was expecting computer scientists, and I got recipe programmers, a lot of them. And, that's not the same thing. And it was a really hard kind of lesson to think about my populations and think about how I do things as a security person to make it actually work for people who are recipe programmers. And does everyone understand what I say when I say a recipe programmer? You have to do this thing. Well, do you have sample code? Yes. You had to have sample code, or they wouldn't do it.
Okay, so we are 12 minutes from the end, and we have actually one question, the last one. But I am going to modify this question a bit, because to tell you the truth, we got enough references out there answering it. So, Brook, from your experience, from your history, take us again one step above the question and explain to us when you are trying to put an SDLC in place, in a place that perhaps doesn't have one or perhaps has a broken one. What are your best practices when you are trying to put that thing in place? How do you connect to the rest of the organization and get people on board with what you do?
Okay, and again, this is stylistic. And I assume you mean not software development lifecycle, but security development lifecycle.
Indeed, yeah.
So let's focus on security. First, I run around, and there are a bunch of things, and you and I were talking about this in email, Izar. First, I demonstrate value because I have to have everyone's confidence. So the very first thing I do, and there's no job that's ever beneath me, although I might tell you that's your job and I think you should do it. Still, I'm always willing to do whatever. And besides, you might learn, right? And this all happens in parallel, by the way. I start doing design work and going into teams and seeing where their problems are and addressing problems. So we knew we had a team that had 72,000, a queue of 72,000 static findings. That went on my list of immediate problems to solve. Immediate, right? Because obviously they weren't doing anything and they were really frustrated and they weren't getting anything. So that goes on my list of problems, right? So I look around and I say that and I demonstrate value by like, okay, there's a threat modeling. You want to come and help this threat modeling? I don't order anybody else to do it. I go and do it. Absolutely. Because I want to show people, yeah, I think I know what I'm doing, and B, I'm here to help and I'm here to demonstrate help. At the same time, I'm running around to every development team and every development leader, and I'm talking to them about what their problems are, how they saw the last administration before I got there. So, you know, what they think they're doing well and what works for them. And I'm looking for gaps between what the VPs tell me and what the people on the ground tell me. Because invariably there are gaps. And invariably they think they've mandated XYZ and nobody in the ground knows how to do that. But on the ground, they're doing something else, which nobody thought to do, but which is really important. And so I'm getting ground truth from everyone. And I'm running around doing that. So I'm showing value. I'm at the same time getting the lay of the land. Because one of the things I want to do is I want to capitalize anything that's working right. Anywhere that people are doing something, I want to praise that and say, yes, that's great. That's fabulous. That's the start of an SDL, security development lifecycle, or secure development lifecycle, whatever you want to call it. That's the start. And that's where we're doing it well. And so I'm gathering all that information. This might take me, let's hope I can get it done in 90 days, but certainly less than half a year. Certainly less than half a year. I'm running around getting this. At the same time, I'm asking decision makers, I'm sort of trying to get a feel for their risk tolerances. What are they willing to take a chance with and what are they not? Because I can't do the risk calculations without knowing that. Otherwise, I'm just BSing. How does this business work? And what are they willing to take a chance with? And what's really like, no, we can't tolerate that. Don't let that happen. And so I'm gathering all that information. I'm literally writing it down. I haven't offered them a strategy yet at all. I haven't said anything. I'm gathering information. This is really critical because without that information, all I'm going to do is impose a bunch of stuff just like the big four, and I'm really going to slam the big four accounting companies because I've had there's some great people there, don't get me wrong, really know what they're doing. But in general, their model is we already know what good security is, and we're going to study you, and then we're going to tell you what the model is. And it's sort of based on the ISO stuff and whatnot. Okay, but that's not very, that doesn't tell what's working well and where the real problems are. So I'm gathering all that data, and then it goes into the Brook cauldron, if you will, the cesspool of my mind. And out of that will come the tactical stuff that's got to be done now, like the 72,000 findings and the 46,000 findings. Big problem. And at the same time, you know, there's lots of teams that have no idea what threat modeling is, so we're going to figure that out. And, you know, all these different things, and then the strategy comes out of that on top of it, saying here's where we're going to go. And then I tender that, and it goes through whatever decision-making processes it goes on, and yeah, that's good, Brook, or no, and you know, it goes through whatever process is organizationally appropriate until there's a strategy. So I know where I'm going, and everybody knows where I'm going, and I start communicating that strategy right away. One of the biggest problems I see time and time again is the strategy is only known by the security department. Well, how do the people who are actually going to enact that get a voice in that? How does it reflect their world if they don't know what you're thinking? So much communication long before. I mean, I kind of take the Apple map of this. We're going to deprecate this function in 3 years. So we're telling you now. So when we actually kill your application, you should have changed it. And so I start communicating about everything and doing all that stuff, and through multiple channels, no one channel, not just a meeting, not just an email, not just many channels, because people learn in different ways. And so you gotta go around and talk to people in their faces. You gotta have meetings. You gotta have all hands. You gotta send emails. It can't be nag emails, but many different ways, wikis that explain everything. I mean, lots of different channels. I'm doing all of this, or the team are doing all of this at the same time, so that everybody knows where we're going. And then you take it piece by piece, whatever's the most doable right now. But holding behind that in 2 years, we're going to be fuzzing, and people not thinking about that today. Besides, and I'm going to close with this, what happens if you announce that we're going to require fuzzing on inputs in 2 years, and 5 of your most brilliant people go out and learn how to be fuzzers? Well, those are going to be your leaders when you get there in 2 years. So, again, I never refuse help. I never refuse help. The most junior person wants to help, I find a place for them, because grassroots is really important. So that's kind of the Brook style.
Yep, and apparently it works.
I will end with this. After I had a very successful team at Cisco and a successful program, a whole bunch of successful programs, the most senior security architect, who was a grade above me, was sitting in a meeting, and that person had the worst group process of anybody I've worked with in years. But nevertheless, he made a statement about something that wasn't true. And I said, yeah, no, our teams all do that. And he said, well, some people have personal charisma or something like that. Some people just personal. So I am convinced now, that may or may not be true, that these techniques do hold value, and other people have been doing them and they have worked for them. So it's kind of field tested, and let's take it away from Brook and put it out there as this is one way to go after these problems. It's not truth with a capital T. There are lots of ways to attack these problems.
Okay, we're getting at the top of the second hour. Time flies when having fun. Brook, again, thank you so much for the wisdom. Always a pleasure. I hope that the people participating had fun as well.
And may I reiterate, if you want to LinkedIn with me, please tell me you were at this session or the other session, or I'll ignore you, because I get like 15 invitations a day, and I don't have time to go check everybody out. And so, just remind me you were here, and then I'm happy to link with you. It would be lovely. But you gotta give me some context. Thanks.
Awesome. And thanks for everyone that sent in questions. They were really good. And sorry if I barked some of them, but we had to explore the whole gamut of things that Brook could give us here. Okay, so
only asked one question personal: how do you stay sane? And like I said, who says I'm sane?
who says that any of us? Okay, so we will stop the recording now.